This is a review of Unit 4, the no calculator problems that we did for our in-class review. This problem teaches you about end behavior. It's checking whether you know what end behavior is and how to find it. So given this polynomial, where a, b, c, d are real numbers, which they would have to be in order for it to be a polynomial, and we're given that our lead coefficient a is greater than 0. So we know that a is positive since it's greater than 0. So what that tells us is we want to find out as x approaches positive infinity, what is the function doing? So I know this is an odd function because my degree is 3. So I know it's odd. And I know that the lead coefficient is positive. That tells me that in general, this graph looks like this. So the parent function looks like this. So it starts in the third quadrant going down and then going up into the first quadrant. So as x approaches as x approaches positive infinity, so as you're moving this way on the x-axis, the function is increasing, so I know it approaches positive infinity also. As x approaches negative infinity, so as you're moving to the left in the coordinate plane, the graph of the function is falling, so I know it's going to negative infinity. Okay, number 2, classify the following polynomials as linear, quadratic, a constant, cubic, or quartic. So linear means your highest degree is an x to the first. Quadratic means x to the second. A constant means x to the 0, so you don't even have a variable included. Cubic, your highest degree is 3, and quartic means an x to the 4th. So this one is to the 4th, so it would be a quartic. B, there's no variable, so I know this is really x to the 0, so that's a constant. C, my highest degree is squared, so that's a quadratic. Oops. This one is to the 3rd, and notice it doesn't have anything to do with the order that they're written in. It has everything to do with the highest degree. So this one is a cubic, and our last one, that is an x to the 1st. When it's not written, we know it's a 1, so that is linear. Now, just as a little side note, if I wanted to write these in standard form, remember standard form takes the degree and lists it like it is in A, where the degrees are in decreasing order, 4, 2, and none. E is also in standard form because 1 and none. However, let's look at one like D. If I wanted to write that in standard form, has to be in decreasing order, so I would write it f of x equals negative 9x cubed minus 3x squared plus 5. Okay, for this problem, number 3, we're asked to state the multiplicity, or we have to consider the multiplicity of each 0 and talk about the behavior at the x-axis. So let's just start out by talking about degree of the polynomial. If I expanded this out and wrote it in standard form that I was just talking about, this is in factored form, but if I wrote it in standard form and I multiplied all of these things out, I would end up with my highest power being an x to the 5th power. In fact, because there's a negative sign here, I know it would be a negative x to the 5th plus so on, so on, so on. Okay, and you would get that by foiling out x plus 3 times x plus 3 times x minus 1 times x minus 1 times x plus 5. you would end up with 5 x's. So I know the degree of my polynomial is 5. So when written in standard form, you can just look at the highest degree to get your degree. However, when it's in factored form, as all of these problems are, you can just add up the degrees of the factors. So 2 plus 2 plus 1. For this one, if I add up the powers, it's 1 plus 1 plus 3 is again 5. And this one, 1 plus 2 is 3. To get my roots, I'm going to look at each factor and see what happens at 0. So here, if x plus 3 equals 0, subtract 3 from both sides, so x is negative 3. So that's one of my roots. At x minus 1, x would equal 1, and x plus 5, x would equal negative 5. So my roots are negative 3, 1, and negative 5. For b, my roots are x equals 0, x plus 3 equals 0, x minus 1 equals 0. So my roots are 0, negative 3, and 1. As far as most missed questions, this is one of them. This x is a factor, so don't forget that it shows you that it crosses the origin. Is what's going to happen there. Okay, for the last one, again, I have 0 as a root because I just have the x, and here my root would be 4. So 0 and 4. Now for crosses and touches, I know that if the multiplicity of a factor is odd, so you're checking multiplicity. If the multiplicity is odd, then I know the function crosses at the x-axis. If the multiplicity is even, I know it touches. So crosses, like it crosses through the x-axis, or touches means like a parabola, and it could be up or it could be down, either way. Okay, so at negative 3, the multiplicity is 2, so I know at negative 3 it's going to touch. At 1, it's an even number, so I know it's also going to touch. And for at negative 5, the multiplicity is 1, so I know it's going to cross. 0, the multiplicity is 1, so it's going to cross because 1 is an odd number. At negative 3, it's also going to cross. And at 1, it's also going to cross again. Okay, for C, the multiplicity is 1 at 0, so it's going to cross. And at 4, the multiplicity is an even number 2, so I know it's going to touch. Okay, I didn't finish writing all of this, but write this in standard form. And I talked about this earlier, so you should be aware that you're not going by coefficients, you're going by powers. This is the largest power, so this would be f of x equals negative 9x to the 4th plus 3x cubed minus 7x squared plus 9x. And this is a quartic function because it's to the 4th. Okay, which of the following are polynomial functions? There are sort of two tests, if you want to think about it this way, to figure out if it's a polynomial function. The first one is look at the coefficients. Okay, that's the number part, and it must be a real number. In other words, no i's, no imaginaries. They can be irrational, they can be fractions, they can be negative, but no i's, all real numbers. And the second test you want to look at are the powers, or the exponents. And the exponents must be whole numbers. That means 0, 1, 2, 3, and so on. So no fractions, no negatives. So when I look at number 1, I see that it does pass the coefficient test, but it fails the exponent test. So this one is not. And it's because of this fraction. Okay, for B, I notice that x is in the denominator, which means a negative exponent, so it means not because of the negative. C, although this is an irrational number, that's still okay. That's real, so that's okay. The 1 is okay. The x is not under the radical, so that's fine. So this one's yes. This one, here we have a decimal, which decimals are real numbers. 9 is a real number, 3 is a real number, and the squared is a whole number, so yes. Parent functions and graph the function. This is a little bit of review because I noticed that this is in vertex form, and I'm just going to start out by sketching. I know that the parent function is y equals x cubed, and I get my power from this. Just like over here in B, it would be y equals x to the 4th. I'm just going to go ahead and graph my parent functions in this pink color, and then I'm going to change and we'll graph the new graph in another color. So the parent function for x cubed, I know that it goes through here, here, and this is the one that in our lessons I talked about, kind of reminds me of a snake in the grass. It sort of looks like this. And when I'm looking at your papers, I'm looking to see that you have these three, and then it climbs very rapidly. For an x to the 4th, they go very much like an x squared, but it's a lot flatter. So instead of going right up like this, like an x squared does, it goes flatter. But then it climbs very rapidly. Because if I do 2 to the 4th, that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So my 2 to the 16th isn't even, 16 isn't even up here. So you can see that it climbs very rapidly. So something like that. It's probably even a little bit flatter than that. Transformations, I'm looking for several things. I'm looking, number 1, is there horizontal movement? Number 2, is there vertical? Number 3, is there a stretch or compression, wider or narrower? And number 4, is it reflected? Those are the only 4 transformations that can take place. So the horizontal movement is right here, and I see that it is. So my parent function has a minus there, so I know this one moves to the left 3. My vertical movement is here, so it goes down 2. There's no stretch because there's a 1 here. However, it is reflected. For B, I know that here's my horizontal movement, so I know it goes to the right 2. I know it goes up 1, and there's no reflection and there's no stretch. So when I graph this, because I know it's reflected, and I know my center point now is over 3, so I'm going to go with this middle point right here. 1, 2, 3, and then down 2. 1, 2. But I know it's reflected, so it's just the opposite. So instead of making my points like this, they go in the opposite direction. And again, when I look at your papers, I'm looking for it to go kind of snake through like that. Okay, for the quartic one, I'm going to the right 2 and up 1, and then you have your other 2 points here, and then you know that it's kind of flat and it goes very rapidly up. Okay, and that's graphing the transformations. You can continue on to the calculator portion.